Hello, everyone. My name is Partha Madhira, and I am from Kyndryl, and I'm here as part of the Cylab partnership that we have between Kyndryl and Cylab. So, the topic that I have today is that we're going to talk about chaos in multi-agent AI agent conversations. So, let's start with this number right here, right? So, according to a recent study that was done by MIT Media Lab that they have published as recent as August, uh, 95% of the Gen AI pilots have failed. Uh, and the reason for that failure is not because the ideas were bad. The reason for the failure is that the implementation of the workflows is challenging. So MIT also noted that as the pilots have failed, organizations have come up with new paradigms like agentic AI, and then they started implementing agentic AI. And then as we are progressing towards that, Kyndryl has actually moved forward and it started to implement these agentic AI applications at scale for our customers. So as part of that, when we try to scale agentic multiple agents and then conversations between them, we found several challenges. And those challenges, although we were able to address most of them through our implementations, there are three of those challenges that required a focused attention, which is what I'm going to highlight today in this talk. So what is this all about, right? So when there are multiple agents that are talking, conversing between each other that are embedded in an complex enterprise workflow, what happens is they're talking past each other, they're running out of tokens. One agent couldn't get the complete context, the other agent takes a different context and responds, and so on. So there are complete chaos going on, as you can see on the left side of the image. On the right side is where what we thought could actually help that situation, which is when agents are talking past each other, there needs to be a component like an oxygen mask in a pressured cabin that could actually help take the situation into control and help the situation, remedy the situation, and then make the workflow progress. The important challenge here is that these failures are not very visible at the infrastructure level, at the API level. They are only visible at the farther end of the flow, which is the business outcome, which is where you don't want things to fail, right? So, but we are not able to detect those either. So that was the challenge. And then to solve that orchestration problem, we evaluated the existing tooling. So as you can see on the left side, there are multi-agent systems. There are the Kubernetes of the world, the Gen AI frameworks, which is AutoGen, and several other frameworks like LangGraph and whatnot. But those are, they provide, some of these tools provide pipelines to actually ingest the data. Some of them actually provide scaffolding to create your agents. But then what we see as an emerging need in this space to actually identify is we need to have systemic reliability defaults. We need to have pre-configured retries, and then immutable state handoffs, and then conversation level health metrics. So we are going to go into detail. I'm going to come up with a specific example for each of those. So if you don't follow those, don't worry about those just yet. So moving on, right, to get to the specifics of these, the three problems that we are mentioning here. The problem statement here is the conversational integrity. So as you can see here, when there are agents that are talking, earlier I think Luho was a professor. I think he highlighted when you ask multiple times the same question to an LLM, it doesn't respond with the same answer every time, right? It's just like human. That's because the intrinsic nature of the LLM is they are indeterministic. That means if you ask for, hey, can I go buy something today? Like what is the laptop for beginners? Then it comes with Acer. Sometimes else it comes up with Mac and so on, right? So due to that nature, in this specific scenario, what we have found out is that agent one writes the output as SKU, and then the discount is 10% for that item, right? And then the second agent, what happens is it takes the data, it processes it, but then it outputs item instead of SKU. As a result, what happens is that modified state actually goes to the third agent, and then the third agent sees that it's an item while it expects the the SKU, and then what happens is it fails at that point, right? The discount is not applied because it did not see SKU over there. So that's one problem. The second problem is the conversational integrity. So here in this case, we have an ordering agent. When a user places an ordering agent picks up that order and it confirms the order. But then in a long running workflow, what happens is down the line, the fulfillment agent, the inventory got updated, and then guess what? Now the fulfillment agent cannot fulfill. So how are we tracking this, right? So the agents did not come into a consensus. So we need to understand that if there is a consensus that has arrived between agents to complete the workflow successfully. So as you can see again here, in both the scenarios, you don't find these errors at the infrastructure level or the API level or the application level. So this is at the conversation level. Now, the third one, and then this is the other bigger problem. And as I was seeing, looking up online, there is a very recent article where the writer on the Medium actually posted that they spent $47,000. They burnt $47,000 before they actually fixed this issue, right? And that is left to the developer discipline. The issue here is that when the agents are talking past each other, they actually lose the context, and because of that, agent one is hung up on some other agent. Then the subsequent agent is actually again hung up, and then that failure actually cascades from top down across all the agents. So that is what we are seeing here. So what we need is, going back to my original point of having a component that can actually control this situation effectively at runtime is the need of the hour. That is what we are seeing in our implementations. So all of this might ring a bell to you all, right? That have been in the infrastructure space, that have been in the DevOps space. So all of you that have been there, this might ring a bell, right? So we had similar issues at the container level, right? So containers, developers did not configure them correctly. Sorry. The developers did not configure them correctly. They did not do whatever that is required. So that's where we had Kubernetes. And then for the conversations also, we need something similar.